Hey, today we're going to be learning how to scrape unlimited emails for free with n8n. So essentially you're being able to build a scalable, zero-cost lead generation engine that automatically extracts businesses, contact emails from Google Maps, search results. It's perfect for agencies, growth hackers, and marketers who need hundreds or thousands of qualified leads without burning through API credits or expensive data providers. Here's what the build looks like. There'll be templates in the links in the description. There's sort of two keys over here and a series of nodes and triggers that you'll need to obviously configure. Anyways, let's get into the training. So this is what we're building. Again, it is a complete automation pipeline that turns 97 plus micro-region search queries through any and scrapes Google results, extracts business emails, and dumps everything into a live Google Sheet. You have the ability to, by the way, interact or directly integrate this into your high-level CRM, HubSpot, or any other CRM that you're using to power outreach sequences. You can even put this into the likes of Install or other emails. But in this raw video, I won't be going over the demo. I'll just be going over the Gamma doc over here. But essentially, in this test, what we did is we targeted California real estate micro regions. And with this setup, we could correctly, you could correctly literally scrape infinite emails from verified business contacts, all for free, flowing into a Google Sheet in real time. And if we let it complete, we could have easily cleared, let's say, thousands of emails. Again, it wasn't infinite. It was more like a couple hundred, right, guys? But you get my point, right? You could basically scrape all of those specific niches, whatever niche you're in, and in those micro regions using n8, and it's crazy. Each execution handles one search query. There's a trigger that fires, which then scrapes, uses HDB, scrapes Google Maps. The code node pars, results, emails, right, straight to the sheet, and with a 6-second delay between queries to prevent throttling, the entire pipeline runs autonomously while you focus on other work. So this approach works at scale because fundamentally there's zero API costs, right? If you've used other scraping tools like Clay or mainly Clay or Apollo, there's no massive subscription fees, pure HTTP requests, and parsing logic running on your own GHL that allows you the ability to scale to thousands of leads without variable costs, eating your margins, micro-region precision. So you can get very, very hyper-personalized scraping through, let's say, California real estate was the example that we used, or any other ones that you want, as well as the CR and really output, right? You can turn that Google Sheet into a CSV, whether through n8n or obviously through uploading it onto a Google Sheet and then downloading it as a CSV file, which then allows you to upload it to your CRM of choice. We use GoHighLevel a lot, but I know people who use HubSpot and so forth. All right, let's get into this. We're going to break this down in steps, beginning with building the core scraper, right? The scraper workflow is the workhouse. It creates a single search query like Bay plus area plus real estate, and it performs a HTTP get to google.com/map/query. We'll build this step by step so that you understand each node's purpose. Just by the intersection, you'll obviously have a reusable scraper that works for any niche, real estate, dental, practices, law firms, restaurants, you name it. We'll be going over the nodes step by step. Again, like I've seen videos where people build it out step by step. If build it, you just need to customize the template that you have here for your own specific use case, right? So for you guys, again, if we go into the execute workflow trigger over here, we'll click on it, just mention the area plus keyword query in here to scrape the destination and the niche that you want to scrape. Okay, next, step 1, set up the HTTP request, the request structure. So if you want to create a new n8n workflow and add a HTTP request node, set the method to get and the URL to www.google.com.map.search.json query. The JSON query variable pulls from the incoming data. We'll feed this dynamically from the trigger workflow. What you'll get back is that Google returns a massive HTML chunk containing bits. This is listings embedded JSON data structures and schema markups. It's pretty ugly, and I'll structure it, which is exactly why we need to parse a code and nodes next. Right, so this is, this bit, right, filtering, removing duplications, and then we'll move on to the loop. Over item 2 next. So in order to test this, right, you want a hardcore query value like Bay plus area plus real estate directly into the workflow so you can debug without the trigger running. Okay, step 2, parse the HTML with a code. So once you add a code node after the HTTP request, this node extracts domains, sites, links, and any visible contact information from the HTML response. The parsing logic uses regex patterns to identify business URLs whilst filtering out Google's own infrastructure's domains. Code stamp is available. So the full parsing code is available in the community resource link. It handles obviously edge cases like URL encoded characters, mock markup extractions, and I can't pronounce this link detection. Copy and paste it directly into your code node. Okay, want to do this? You want to run the code after a successful HTTP request. You'll see its output, a list of Canada domains, but many are duplicates or junk like Google, user, content, com, or gstatic.com, and schema definition links. That's what we filter next, right? Which is specifically in here in the filter icon. Okay, double click these, by the way, to select your nodes. Step 3, filter out junk domains. So once you added a filter node, again, into the filter node, after the parsing code, user, rejects, pass into exclude unwanted domains such as Google users, contact, the staff, YouTube, Facebook, don't want any of that on. You want to then remove duplicates by adding a remove duplicate. No, you target the URL field, set it to remove repeated items within the current input and business, and then you want to test the output, right? So a query, a typical cool. Query starts with 32 raw URLs and reduces to 18 to 20 unique high-quality business domains after filtering duplications. Nice. I hope everything makes sense because we're moving on to part 2, which is looping through each business domain. Now that we have a clean in-business URL, we need to visit each one individually to extract contact information. This is where the loop node comes in. It iterates through the filter domain list and performs a separate HTTP request for each. Criticals is to enable error handling, right? So it's a loop node to continue on error and why the error outputs were no upload. When scraping dozens of URLs, someone inevitably returned to 404s, which is fine. Timeouts were anti-blockers. Without error handling, one failed request stops the entire workflow, right? This is, I've done this before. Like, it was really annoying when you set it up and it just stops working because one silly step or error inside the loop. So HTTP requests to JSON, URL, the code node to parse emails from, page, HTML, filter to validate email format, and then continue even if the page fails to load. Right, so I'm going to show you what that looks like in here, in this node specifically. Leave a right, and there you go. So you should understand what schema table on JSON looks like if you don't watch our previous videos. Right, you get my point. So test the loop with a small batch first. Again, you want to test it with 5 to 10 domains. You'll see some complete delete in under 2 seconds. Others may take 10 plus seconds depending on the server's one's time, and the error handling ensures slow or failed requests, so don't halt the workflow. Step 4, you want to parse, say, emails from business pages. Okay, so add a code node inside the loop that scans the return HTML for email addresses. The parsing logic looks for mail to links, visible email patterns, and structured contact data in footer elements. This code normalizes email formats, strips URL query parameters, converts to lowercase, and removes any non-email junk that regex might accidentally catch. Some pages return 0 emails, that's normal. Others might return multiple contact addresses. For different departments, again, these are the statistics. Expect 60% to have valid pages, 2.3 average emails per page, and about 40% with no emails found. Step 5, aggregate and deduplicate final results. So after the loop completes, right after you finalize this, there's a couple more things that we got to do. So we got the HTTP request, number 1, which obviously aggregates and deduplicates final results. So after the loop completes, or parser emails need to converge into a single clean list using an aggregate node with a merge list enabled, which combines all email outputs from the loop iterations into one unified array field. Next, add a spill it out node so each email becomes its own individual item, again required for the sheet to append step. Finally, run removal, removed duplicates one more time on the email field, and this catches cases where multiple business pages references same corporate email address. So why do we have double deduplication? Well, the first deduplication removes duplicate domains, then the second removes duplicate email that appear across different business websites, common word, franchise locations, share parent company contact. Yeah, and obviously you want to go after franchises because if you can get one, you can get all 10, 20, and 100 of them. If you're an agency owner, cartridge consultant. Number 6, you want to send results to Google Sheet. So add a Google Sheet, append row node as the final step. So authenticate your Google account, select your target spreadsheet and name, and then map the email fields to a column header, right? All right, it's over here. So you've gone through 1, you've gone through 2. Again, it goes back here. If it fails because the accurate spits it out, removes duplicates, and then finally goes to the Google Sheet over here, maybe you can actually all appropriate Google Sheet by integrating it up here. That's it. Okay, I'm going to be collecting the correct sheet and then adding in emails column on the left-hand side so that it correctly scrapes it. Okay, cool. Your sheet must have a header row. Yeah, like I said, email, which is the source query scraped, comma and scraped data for the mapping to work correctly. Each unique email becomes a new row appended to the bottom of the sheet. Test with a single query run. Again, you should see 15 to 30 emails populate into the sheet within 30-60 seconds, depending on how many businesses domains work. Scraped. Cool. All right, and now we go on to part 3, which is the trigger orchestrator, right? You want to build the trigger workflow that runs this at scale. The scraper workflow handles one query at a time. Now we need a trigger workflow that feeds its, hundreds, depending on the area that you search, different search queries, and manages execution pacing. This orchestrator is what enables true scale, and it turns a single query tool into a production and generation engine. Firstly, you want to load the query list. So start with a webhook or manual trigger containing your form you want of micro-region queries. Then you want to execute the scraper. So use the execute node to call the scraper for each query in a wait between runs at let's say, a 3 to 5 second wait time between each node. I didn't add the wait step yet, but you give up a point. You just got to click this and put the wait step in here. And then last but not least, continue on error. So in short, one failed query doesn't stop the entire queue. And there you go. You should be able to generate your search query list with AI. So how do you create, let's say, a 97 micro-region queries without typing the manual? You use an LLM like Cloud or ChatGPT, and here's the exact problem that you can use to generate, let's say that's generated in our California real estate query list. Produce, again, copy this into GPT, and you get essentially your own micro-neighbored search queries. Okay, the AI returns a properly formatted list in seconds. Copy-paste the output directly into your trigger work. Flow as a JSON array, and then you can adapt this for any vertical, dental practices by city, law firms by specialty, and region restaurants by cuisine types and neighborhood. Pretty awesome. All right, so what we're going to do, we're just going to the overview, a little bit more common issues that you might experience and so forth. So when you set up execution, pacing, resilience, the wait node strategy, add a wait node set to a 6 second between each execution workflow call. This LA serves two purposes, right? Because it prevents Goo from flabbing in rapid-fire requests as bot traffic, and it avoids race conditions where multiple workflow runs try to append the same Google she sells simultaneously. So you can lower the wait to 3 seconds if you're confident in your setup, but 6 is typically safe. Again, depends. You can basically go to sleep, upload a bunch of your search query lists, and then wait until AI scraped a bunch for you. Next, you want to continue on error is critical. So if you set the execution workflow node to continue on error, so we sync, go failing query doesn't halt the entire, however many query queue you have, why the error output to a separate branch. So if you want to log failed queries for retrying laser without this set one bad query, malformed URL, timeout, etc., stops all downstream queries from processing. Here are some common issues that you might experience. Part 4, which is troubleshooting and optimization, right? You might have workflows that stall after 2 queries. Typically, the problem here is that the trigger workflow stops processing after only a few queries, even though the list only contains 97 items. Make sure to check. Thank the node inside the loop. As always, output data in their settings, right? So 0 results run needs 0 result runs. Need to send a completion signal. Or the orchestration assumes they're still running. Next, some you must appear multiple times. Again, we discussed this before. 4, the same email address shows up 3 to 4 times or on 3 to 4 different rows in the sheet. You must verify you have a remove duplicate node after the aggregate step, and that is set to deduplicate on the email field specifically, not in the URL or domain. And then last but not least, the HTTP request timing frequency times out. So typically 30 to 40% of pages requests fail, but timeout errors reducing overall email yield, which is fine. You want to increase the HTTP request timeout settings to about 20 to 30 seconds because some business sites load quite slow, and also ensure continue on error is enabled so timeout doesn't hold a workflow. It is what you can expect, right? So the execution time varies significantly based on query complexity. Businesses page queries, each query returns. Here's what you can typically expect, right? So if you want fast query, 9 to 20 seconds. You want to have board searches in high density areas that return many quick results. So let's say Los Angeles, real estate, lots of businesses, fast parsing, medium queries, right? Again, this is a suburban or niche. So that returns 10 to 15 businesses, slow queries, micro regions with a few results, but slow loading business websites. And last but not least, total runtime for 97 queries. You can expect between 30 to 60 minutes for a full run, planning on a mix. The system is resilient, and fast queries finish quickly, while slow ones, continuing parallel across loop branches. Again, we have advanced upgrade ideas that you can add on to this, right? So AI-generated query lists, imagine that. You can replace the static 97 query list with an n8n LLM agent that generates micro regions on demand, prompt the model to produce location-based search strings, and then format them for Google Maps and feed them directly into the trigger, fully autonomously. Query generation, this is sick. This is something we'll probably build out as well. You can add lead qualification, scores, because not all lead is created the same. You can categorize them based on review counts or site content, or score leads based on signals like reviews or has bookings, and only push high quality leads to your CRM, which saves time with not working with your ideal ICP. Then last but not least, I always go ahead of those RCRM. You might something else. You can skip the Google Sheets entirely and just push qualified leads straight into GHL by API, auto tagging context with me. If you want to get the complete workflow, again, in the links in description, you can get access to that. And as well as that, if you want your own custom version and you don't want to build it out, simply, there'll be something here for you to reach out to us for us to build it out for you. Again, start building your lead engine today. I'll end with the leads niche specific, again, CRM ready and resiliently designed. Grab the workflow template, import it to n8n. Yeah, so see you. Hope that was helpful. Thank you for watching and appreciate you listening to me all the way to the end.